As it turns out, I'm a dirty fucking liar. I have some time to do stuff today. So I'll just continue where I left off yesterday. So the thing was that the intersection check doesn't really seem to work. We always get a straight line. So when I put in like 15, 15, yeah, then it's going through this, and this is actually okay. Let's go to 10. Oh no, wait. 15, 10. Okay, now it's very obvious. So for some reason, it's always saying, yeah, we're intersecting all the boundaries, but obviously we don't. So let's see why that would be the case. I think since I have burst disabled, I can debug this. Invoke. Oh, no, that was the wrong button. This is the button. Okay, so yeah, we're here. So we have our rects. We want to go to this point. And this should contain like 1, 2, 3, 4 rects now. Rect list. We have a length of 6. It's a bit more than expected. So this should be 0, 0. Yeah. Oh, okay. This is also 0, 0. So that's already where the trouble starts. So we don't need this. Contract. Came from yeah, okay, so we are already putting in the last rect, and then this puts everything in until the start rect, because we're using the came from before. Okay, so we don't need this. But that's probably not everything. And 15. No. Was it 10, 15? No. 15, 10. Okay, so this is why we have more. Let's go with 16, or maybe. No, wrong again. 13. Okay, so now we are clearly in this one. So the shortest path is bop, 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 bop. So we have 4. Invoke. Okay. We want to go here. Okay, now we have 4 acts. That seems okay. And they're all different. Okay. We start at 1 because we do a -1 here. So now we have the first 2 rects. We get closest point A and B. So this is 10, 11, and 10, 28. So 10? This is 1, 2, 3, 4, 5. Oh no, wait. We are starting at the back. So this is, can I count this from here? 1, 2, 3, 4, 5, 10. Okay. So that checks out. And Z11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, I think that checks out. So 28 seems good. So that is these 2 points, 10, 11 and 10, 28. So that should be all right. But then we have 7, 7 to 7, 44. Yeah, that checks out. 5, 4 to 5, 44. Yeah. And that was the last one. So now we start by adding the last position to the path. Overlapping segments is 3. So we don't do this. We are at 0. Current point 2D. So this is the goal position that we're currently at. 15, 13. Yes. Then we make a straight line from our goal position to our start position. 0, 0 to 15, 13, yeah. And now we check if this intersects all the overlapping segments, which it should not. It's not the method we need. Our start index is 0 and index is 3. Okay, so our line is from start to finish. The first line we are looking at is this one from 10:11 to 10:28. So this is this line right here. And it does not intersect this. So this should return false. O1 is not O2 and O3 is not O4. Okay, so I have no idea how this orientation thing works, which is a problem. ChatGPT. Okay, let's check the orientation again. Check for general case. If points C and D lie on opposite sides of line AB and points AB lie on opposite sides of line CD, then the line segments intersect. And it gives me this. So maybe that's just the wrong way around. Just try to say not this. If that doesn't work, then I fear I will have to try and understand this orientation thing. Oh no, don't make me do the math. What was it? 10, 13? Okay, no. This is not right. Hmm. 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 Okay. Fuck. I have to make sure that this is correct. I can probably find some C# code. C# line segment intersection. How to check if two given line segments intersect. Given two line segments, blah blah and blah blah, find if the given line segments intersect with each other. Before we discuss the solution, let us define the notion of orientation. Orientation of an ordered triplet of points in the plane can be counterclockwise, clockwise, collinear. The following diagram shows different possible orientations of A, B, C. Okay, so we got clockwise, we got counterclockwise, and we got collinear. Okay. How is orientation useful here? Two segments, blah, blah, and blah, blah, intersect if and only if one of the following two conditions is verified. General case. P1, Q1, P1, and P1, Q1, Q2 have different orientations. And P2, Q2, P1, and P2, Q1, P2, Q2, Q1 have different orientations. Okay, so we have P1, Q1, P2, Q2. So for these three, we check that this is counterclockwise. And this one has to be clockwise or the other way around. And P2, Q2, and P1. P2, Q2, and P1, and Q1. And these have to have different orientations. Okay. Special case, they're collinear. We don't care about the special case. We don't have that. C#. We have points, one segment orientation. Orientation QY minus PY times RX minus QX minus QX minus PX times RY minus QY. Yeah. Okay, there's one important difference here, and that is we get the value of this. Oh, this is float. Okay, sure. And this has to be integer. And then we say if value is 0, then return 0. Else, oh, Just return if value is greater than 1, then return 1. They have 1 as clockwise and 2 as counterclockwise? That doesn't really make a lot of sense to me. But it should be the same. So I'm going to use 1 and -1. And then this should maybe work because these were floats before. And we don't want them to be floats. Because then, of course, this is garbage. And then we do the 4 intersections. And then we check 01 is not 02 and 03 is not 04. Since we don't consider the special cases, this should be enough. So let's test this 7.7. That is just about in. If we go one further to the right. Haha, yeah, now. I mean, kind of. We should really be here. Let's go 15, 13. 10. So this works as long as we have a straight line. We use that straight line, but this, it almost makes sense. Okay, 12, 13. So what should happen is first we check this line and see, okay, this doesn't work. But then we should check to this point, and that should work. So we should really go bop, bop. Let's see. Okay, so we go here. We have our straight line. This fails. Okay, good. And now we go to the last. Oh, actually, I'm looking at this from the wrong perspective since we're starting from the end. We're looking from the end. And so this line would always hit this. this raised bit and never be here. And then but then it should be at some point of this line and then go straight. So we shouldn't find anything here. Wait, this says intersects all? That's not right. Straight line from 1213 to 513, which is, wait, 513? Overlapping segments. This is like 5, 5. That's 1, 2, 3, 4. So this is 5, 4. That's the point that we should check against. And that is not what's happening. So we go here. Current line segment is 2. We have 3 line segments. Yeah, so we're looking at the last one. Closest online. Overlapping segments. Number 2. 5, 4 and 544. Yeah. Current point 2D is our goal. Project P on AB. And that gives us 513. No, that's not right. 513? That is not right. Wanna go here. We got the line 5, 4 to 550 found our point 1213. Oh wait. That is right. That is the closest point. Yeah, I'm dumb. So it's not the closest point to our start, but the closest point from the end. Because we need, yeah, we need this. That's the closest point to there. And that would also not work. So then we need the closest point there and the closest point here. So we go there. And from there, it's a straight line. So wait, this is in the way. So we have to go up, 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 up. We have to go around this, and then from here it's a straight line. Okay. So it's not at this point. It's the last point that we were checking against. Load current goal 2D. Current goal. And then if this doesn't work, we say current goal is closest online. What was it? 1213? Okay, so that looks better. But where do we get this? This is right. But this is weird. This should go through here. Hmm. Hmm. This is not right. Use something closer. 7, 6, 7. 4. That should not work. Hmm. Oh, we are Okay, so this case is not right. Start plus. We have one line segment. Then we still have to check. Yeah. So if we go out there, so we don't do this. And this should never, this doesn't ever add the start position. What was it? 7-4 or something? 7-4. Yeah. No, that looks correct. Index out of range? Found line. If we only have one line segment, then we only have to find no, wait. Why does this not work? We only have to check one line. We only have to find the closest point on that line. to the start. Okay, so this does not work. Yeah. We have one line segment. Current line segment. So this should be equal to I. Six. Or yes. 5, 4. That seems correct, yeah. Shortest way, blue, 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 blue. Mm-hmm. 277. That's a straight line. We want to go around there, then this is not correct. This should not work. 8, 7. So first we do the straight line. This obviously should not work. And then we go to the last line segment, which is this. Get the closest point to the start, which is this. And then we should see, okay, this straight line does not intersect with that boundary. Closest point, 5, 4, yeah. Straight line from 8, 7 to 5, 4, yeah. Intersects all. We're checking from 0. Oh, we're not checking everything that we need to check. So, wait, no, we only have to check this. Because the, yeah, okay. And then, let's do this once again. There's only this one we have to check because this line would always intersect this. But this should return false. So, oh, because I am saying smaller. So, okay, so this -1 is not right. Eight, 7, invoke. Okay, so that also looks correct now. So let's say 13, 11. So that's a straight line. 10. That's just about a straight line. Of course, we have to take care of the corners at some point. But all in all, this seems correct. And if we go one down, oh, this is too much. Seems like we end up in an infinite loop somewhere. Current line segment. This one. Overlapping segments, we have 4, which should be 1, 2, 3, 4. Current goal 7, 7. 7, 7? Um, 0, 0 to 12, 10. Yeah. Line segment 10, 11 is here. That shouldn't work. Now we're at 0. Do the same thing again, but it works. Line true. Straight line. 12, 11 to 12, 11. I is -1. Why is I -1? So now we're looking at the exact same thing again. Current line segment 3, 2, 1. Ah, so this this -1 is not correct. We set I to current line segment. Okay, so let's set I to 100, so we break out of here. So we do this. Maybe. Okay, Unity is the upset. Okay. What was it? 12:10? Yes. Okay. So that's also good. 9, 8. Seven. Is this really shorter than this? It seems unlikely. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Hmm. If we go 1, 2, 3, 4, 5, 6. Hmm. Wait. Hmm. Hard to say. Hard to say. It probably is, because going like this saves a lot of time. I'm not sure. Okay, I think we're almost there. So, this would be a question for the actual A star part, where we look at the rectangles. Could be that I'm overestimating something. But I mean, this seems reasonable. Let's go somewhere else. This. Okay, yeah, so this works because we're looking at this point right here. I should be more specific with the points, because now we're not only looking at the center points of everything. So when I am here and I say draw all the lines, draw path, path, position. Yeah, so this is truly 0, 0. So we're always in the middle. But for the intersections, okay, then for the intersections, we are also using not the lines I draw, but like the center points, which is not correct, actually. Okay, I'm gonna be right back. Okay. Where was I? Oh yeah, the positions. Oh. My points. So when I draw my rectangles, I add these offsets. Hmm. And when I get my top right corner, I add 1. Where's my node rects? Node rect. Yeah. This is not super nice. My bottom left. Maybe I shouldn't define them in terms of bottom left and extends, but in terms of bottom left and top right. But then that's also not really what's the word? Obvious what it should be. So right now when I have a rectangle of size 1, so if it was like only this, and this is 0, 0 with extends 1, 1. I think. Or is it 0, 0? I'm not even sure. It must be 0, 0. Because otherwise the 1, 1 doesn't make any sense. How do I determine the extents? Node merger. Voxel node merger. Hmm. Hmm. Extends starts at the 0. And then whenever I can merge to the right or up, I add 1 in that direction. So maybe this should just start at 1. I just take the bottom left and then set the top right? That might be better. Let me do one commit first. Oops. Button. All right. I mean, it doesn't really make a difference. Let's start this at 1. And then I don't need this, I think. Entity does not exist? What entity? No larger. Okay. So we have to start at 0. Because if we don't, then this doesn't work anymore. But I can also just say, no, maybe not. If I start at 0, 0 and my extents are 0, 0, then I have one block. My top right is 1, 1. I think my thinking is just not right. My bottom left, my block is 0, 0, and my extents are 0, 0, then my bottom left should be minus 0.5, minus 0.5, and my top right should be 0.5, 0.5. Because 0, 0 is my center. So I should say into bottom left, this bottom left minus, yeah, this should be, I want to keep it as an integer. And then my bottom left must be 0, 0. But then I can't say that the center of my block is the position of the block. Then it must be the bottom left corner. Yeah, I think that makes the most sense. And then we add this back in. So we just have to say let's not use the offset. We just use the bottom left. Of the oh wait, we're using no. These are two different things. The rect, yeah, we need the center of the rect here to draw the bounding box. These positions come from the pathfinding. Something's not really making sense, yeah. I'm not sure what it is. But somewhere my thinking is incorrect. Can we start? So let's say I want to go from 0, 0 to 1, 1. Then I have this, yeah. I want to go to 5. I get straight lines to the center of the block, which is what I want. 1, 2, 3. This is not right. This can't be right. So my path finding through the rects is not completely correct. This one is definitely incorrect. Hmm. Mm-hmm. And we should be looking at this point right here. So, wait. We start from here. And then my rectangle is this and that. Hmm. Hmm. This is also not right. Hmm. Hmm. Why do we go from here to there? Even if this is our path, we should go. Oh yeah, we're going from the closest point from here to there. But that, I mean, that doesn't even work. That does not work. So we're starting at 513. Then we're looking at the X and Z. Drawing a straight line to the finish. No, not to the finish, to the last intersection, which is there. That obviously doesn't work. Oh, and we would also have to consider the y-axis, huh? Yeah. Current line segment 2. So this doesn't work. This should also not work. But it does. Line segment 1 is this. Something in my setup is garbage. Let's draw a picture. Maybe it helps to visualize. So we have our grid where we have several voxels and stuff. And then we say this is 0, 0. So this would be 0.0. And then this is 1, 0. And this is 0, 1, and so on. And when we're standing at 0, 0, we're at the center point of this block. And when we have a rect that contains multiple blocks like this, and then this would start. I've drawn this wrong, it should be down here. But it still works. Then this would be my bottom left. And I have extends 1, 1. I should have extends 1, 1. And then I say, okay, my bounding box is 0, 0 to 1, 1, but I have to add 0.5 in all directions to get the border. which means when my position is 0, 0 and my extents is 0, 0, then I have one block. Yeah, I think that makes probably more sense. Because right now I'm saying this would be extends 2, 2. But I think that's just causing problems. Okay, so let's say we don't do this. This is just 1, 1. Let's make a smaller map. Oh no, I want to make a new map. One new world. One. Let's. Oh no. Dum 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 dum. So now we have one block right there. Serialize. I loaded the wrong thing. Okay. ECS stress test. No need to save. This is not. Okay, now we got it. So we got 1, 2, 3, 4, 5 rects. And we still have tons of entities that are empty. What? Why do we have so many empty entities? What? Entities, journaling. Okay, so somewhere in here we create tons of entities. Voxel stress test. Start, deserialize, create graph. Okay, so far, so good. When we create the graph, that's probably where all the entities are spawned. But we should have 16 by 16 and not thousands. Where are we creating all these entities? Create graph. We don't merge nodes. Okay, so we only create the graph. We have 308. Should have 16 times 16, 256. That's still a bit too much. Oh, wait. No, they don't start at 0. So we have 308 minus 51. Yeah, okay, so that's about right. And when we create the rects, then we suddenly explode with entities. Why can you not show me the entities? Thank you. Yes, we're creating thousands of empty entities. Then we are creating some rects. This is one rect. There's another one. Okay, somewhere in the process we're creating empty rects. Voxel node merger. Oh, yeah. That's because we're doing this for all positions. Oh, yeah. So we have to do this before we create a new entity. First, we have to check if the thing we're trying to create or the voxel we are trying to start from even exists. Okay. Now, okay. We should have 1, 2, 3, 4, 5, if I'm not mistaken. Doesn't. Oh yeah, because okay. Oh, I skipped some steps. 1, 2, 3, 1, 2, 3, 4, 5. Yeah. So we put this back in. Okay, so we have 5 rects. This doesn't show again. Amazing. So our first one is this 0, 0 with it extends 1 and 1 at height 0. The drawing still works. Even though I removed the 1, 1. Draw rects. Node rect extends. I'm adding another +1 here. What? The bottom left. So bottom left is now this point. Plus extends is this. So this is really all I need. I just need the center of these 2 points. Okay, so now this is incorrect. We start at Oh, wait. I have to divide this expression by 2. Okay, this is getting more wrong. This the center point 0, 0, 1, 1. So this is 0.05. And oh wait. We don't add anything here. This should be 0.05. And then we have the extents. The size is 1 in each direction. Yeah. Okay, now we are in the center, but the extents are not correct. Extents is 1, 1. Oh, okay, so extents is not the same as size. We have to multiply this by 2. Yeah, and then this correct is correct again. So now why is all the rest nonsense? Let's see. This is 0, 0, 0, 3. So this would be here. Right. 0, 3. 0, 2. 0, 1, 2. 3 and 0. 0, 1, 2, 3. And that has 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ah yeah, minus the start. And 1, 2. So that is this. So 3, 0 is here. And then 15, 2 is here. Cube. 3, 0. And 15, 2. That could be my rectangle. And then I take the center. Oh, this should be top right, huh? And not extends. Still no. So this is my 0, 0, 1, 1. 0, 3. 3, 0. 15, 12. 15, 2. So my center is 9, 1. 9, 1 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh yeah, we're starting at 3. This is 15. So the middle is here, yeah. And my extents should be 1.5. My size should be 3 times 13. My extents are 12 and 2. I can't just multiply by 2. Or do I just add 1, 1 here? Okay, yeah, I just add 1 to the extents plus in float to 1. Okay. Now this is correct. Let's fix the height. This should be 5. Okay. So now the thing is that I define my rects in terms of the center points. So these two rects here, they don't share an edge anymore. So I have to make a I have to differentiate between what I'm looking at. Yeah, can I extract this as a method? Get cube. And then I do the same here. Center cube. Okay, so if I draw all the lines again, draw connections, does not work. Why not? Because I'm not using the neighbor. Okay. Ah. Yeah, okay, that looks to be correct. So now for the shared edges. We wanna use this line in between. So this rectangle really ends here and this one ends here. But we want this in the middle and we want to ignore this part and this part. We only really want to look at everything in between here. Hmm. Okay. Graph, rect note. Oh, fucking hell. Graph, rect note. Why are you doing this? Jesus Christ. Get closest point in rect. Hmm. I'm gonna delete these. So we don't have any old references. Okay, so for the overlapping segments, actually, what we're doing here is we don't look at this line in between. Let's also delete this. And voxel A star, voxel lookup system. So when we're saying we're here somewhere and we say get closest point in rectangle of this, then we are looking at these points. So we would clamp it to here, which is actually already what I want. So I think maybe we don't have to change this after all. A star. So let's use this again. And so we always walk from the center to the center of a block. 3, we go there. 12, 4. Okay, so the problem now is that, okay, we go to this block right here and we do our line check, but we ignore this. So, we only check against. Oh, wait, we should be checking against. No, we're checking against this line right here. Aren't we? No, wait, I'm looking at this from the wrong direction again. So we have 1, 2, 3 line segments. So first we cast from here to there. And then we check against this. And this probably maybe works. But then we check against this. And we don't. Then we check against this point. And we check this line, don't we? Yeah, maybe this doesn't work after all. I don't really get why. Don't get why. Um, so goal 12 4. We have 3 segments. 5-0, 5-2, 5-0, 5-2, and 10-3, 17-9-3. Is it 10-3? Yeah, this is here, just a very long edge. And then we have 12-4. 0, 1, 2, 3, 4. This is this line. Right. Twelve, 4, 10. We are not looking at this. Should have 1, 2, 3. Oh yeah, no, okay. No, actually not okay. This is the 12-4 point. This is not correct. We should be looking at this. 11-4, if anything. So we're starting by rect 1, get closest point in rect this. Okay, we have to take another look at the line segments. So we are here. Our first 2 rects are this and this. I want to say rect 1, bottom left 12-4, and this is bottom left 10-3. Yes. And then we say from this rectangle, we want the closest point in this rectangle. So from the bottom left, 12, 4, which should be 10-3. Ah, yeah, okay. So this should be 12-3. It should be 12-3. What is this 12-4? That is not correct. Let's go again. bottom left. Target 10, 3. Ah, I'm doing this the wrong way around. Well, okay, now this starts to look correct. Yeah. Question is, why can't we go from here directly to there? Because we're looking at the center. So this would be like correct if this wasn't walkable. So do we want to check the surrounding blocks? Or do we just accept this? It's a little... It's not completely wrong, but it's also not completely correct. So... But I think to make it completely correct, this would increase the complexity by quite a bit. I want to say this is probably fine. It's just a very small difference. It's probably not worth the effort to fix this. No, this doesn't work again. It should go like this. What is the issue here? we're going so all of these line checks probably fail. And then we do go directly. So it's this case. I think that's doing this. In root. So all of this should fail. No, it doesn't. Current line segment 0. So we're looking at this. And since we are not checking, I mean, yeah, we're looking at this line right here. And of course, this intersects. Hmm. Hmm. Um, so we should say we're doing this until I plus 1. And then if that doesn't work, we have to look from here to there. So we would say not this. Right. Relevant segments, I plus 1, closest CD to AB. Like this, perhaps? Mm-hmm. Eleven, 5. No. Eleven, 5. Hmm? Segments. Yeah, no, we're looking. From one segment to another, but we want to I think we want to do this, but the other way around. Uh, we don't really. Hmm. 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 How do we do this? Maybe it's better after all to take the real line and then we'll have to add some buffers where necessary. Hmm. 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 Segments. So the problem is that we're using this line right here. And then we just go straight from here to there. We used this line instead. Then that would work. Then we would go from here to there. So, um, closest point in rect. If we say we make a different method, get overlapping line node rect other. Then we still do this. Other. No, wait. Go to P1 other bottom left and P2 top right. But then no. We want so for instance we take these two rectangles and then we want exactly this line segment between the two. So when I clamp the bottom left and top right to this, then I get these 2 points. So I just have to move them by 1/2 into this direction. And how do I find out the direction? So I do this. And then I would say maybe if P1x is greater than other bottom left x, then this is to the right. So we have to do this, and same for P2. Else we do this. That's probably a good formula for this, but I can't think of it right now. But this should also do the trick, and then we return P1 and P2. And then in here, don't do this. Instead, we say overlapping segments at rect 1, overlapping line rect 2. And now oh yeah, the direction, the order should be irrelevant. New line, item 1, line, item 2. Oh, here we are. What was it? 11.5 or something? Yeah. Now we're walking on the line. Which is also not what I want. And also this. Hmm. Hmm. Okay, I need a better look at this. So and this is really annoying that it doesn't first compile anything that's not in a job for some reason. Because all of this code has to be in here. Otherwise, burst is like, get full path. I know. I can I take this and put it also in the gizmos here. Draw what do we call this? Draw draw intersections. And we say if draw intersections, we have to get all the rects which we already have. Rect entities, entity manager, get component data node rect. And then, oh yeah, but these are not ordered in any way. So, I have to find adjacent rects of. Oh wait, do we have the rects in the path? Not here. Starting to get sick of Visual Studio. I cannot jump to the definition for whatever reason. It's incredibly annoying. I always have to be like, oh yeah, I do this and then copy here and oh. Fucking hell. Um, yeah, we don't get the rects out. Then we make this an out, I guess. Out, rect this. And yeah, also here. Reckless default. This is not great. But now we can say in addition to this, we also want a node rect buffer. Node rect buffer. Oh, just copy this. Oh, no, wait. This. Oh, we already have this path buffer thing, which we can use. Okay. So let's use that. Actually, now that I think about it, we don't have to do everything in one go, do we? We could, in a first pass, find all the rects that we have to traverse. And then in a second pass, find the shortest pass through these rects. That might actually be reasonable. Okay, so for this, we also add a path buffer. Wait. I'm having another thought. But I think it's wrong. I was thinking that since we only really need to look at the intersecting line segments, would it be enough to find the shortest path from each line segment to the next? But it's not really. Because if we have 3 line segments like this, for instance, and we're here, and we need to go like there, then the shortest path is obviously this. But if we only look for the shortest path to the next line segment, then it would be this. But if we take the angle to the point where we have to go, maybe I was making this too complicated all along. We always have this line, and then we just check. We just take this line and get the nearest point on this. So we have a couple more, I don't know, like this. And this is my target. And then I do this. No, that doesn't work. Because I would have to go like this. And then like this. That's the shortest path. So I think what I'm doing is actually the only way to do it. It seems weird. It seems weird that there's no straightforward formula. To calculate this. It seems strange. That I have to check this and see if this goes through everything. Then I have to check this. Then I have to check this. Then I have to check this. And then, okay, yeah, this works. And then from here I have to do it again. Maybe I should ask someone who is good at math. Hmm. 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 Okay, whatever. Path buffer. Voxel A star. Path buffer. Path buffer. Path buffer. Clear. Correct list. Path buffer. Create entity. Oh yeah, we need the entities. Path buffer. Rect list. Dispose. And I cannot go to this method because all this doesn't compile. I have no idea where I should be going. It's a mystery. There's only a recent thing that this shit doesn't work. It always used to. Notes. Correct. Oh, this is reckless. And this is rect entities. Node rect. So I also have to make an array for the entities. At current rect. And then here we add current rect again. Yeah, that should do it. Okay, and then in here, we say entity manager path. No, get buffer path buffer of pathfinder buffer. And then we go through this. This rects. Then we need the entity manager, get component data, node rect of rect. This node I'm contemplating. I want to go back to just walking at right angles. That was so much simpler. Like a lot simpler. Shockingly. Um, no, direct. This like so. And this is my line. And then I want to draw what color do we use? Gizmo's color is color blue. Gizmos draw a line from line item 1, line item 2. To can I cast? Yeah. For some of these, they added casts. For others, they made implicit casts, and for others again, they haven't made casts at all. Kind of weird. Okay, so now we check draw intersections. And that doesn't work. Oh yeah, if we only have one. Wait. Oh, right. So keywords this. Wasn't this greater? I think that was greater then. No. So it was this. Okay. So that's weird. Intersections. Oh, wait. I'm drawing the YS up. X0 line item 1 Y. Mm. Um, Pathfinder. Not null. Where is it here? Oh yeah, I should draw this at 0 height. We should draw this at like, I don't know, 0.6. Okay. Okay, so we can see that this line is not completely correct. Not correct. We say overlapping line from this to this. Get closest point if I don't do the adjustment. Okay, so yeah, that is the correct line. We just have to move it over here. And with the X that worked. If P1 X is bigger than, only comparing the bottom left. Can I? So I could just get the direction from this to this. But then I also have to project. But how do I know what to project on? Because it could also be a line like this. No, I think I know what my mistake is. I have to compare the rects. If my bottom left bigger than your bottom left, then I'm on your right. And if my y is bigger than your y, I have to use the top right here. Um, no, not quite. Okay, I think we have to say something like top right x is the same as other bottom left x minus 1. Then we are to the left, as if it's the other way around. So we have bottom left here and top right there. Plus 1, then it's like this. Top right, y, y. bottom left, top right, +1, I think something like this ought to work. My x equal to your x -1, so we put it there. Yeah. Almost. Wrong direction. Plus, minus, minus. Now we got the correct intersection line. And now if we go not that far. This is nonsense on so many levels. Huh? Yeah, I broke something. We're getting this, and then for some reason we're going there. I changed stuff here. Let me check what I changed. Voxel A star. No, nothing changed here. And we are completely missing this bit. Why are we missing? Rect 1 overlapping rect 2. Oh, wait. Ah, yeah. The The Y thing also doesn't have the right direction. Okay. And now this looks better. Okay. Yeah. This is what I was looking for. Now we get this and we don't walk through this edge anymore. So if we wanted to be really crafty, we could check the surrounding tiles or rather rects to see if we have to remove this bit, but I think that's just too much work. For a very, very small optimization. So in terms of efficiency, this would cost too much. Okay. Maybe now we have it. Yeah, this actually looks quite good. This is a very interesting case. I'm going from there to here, and we just about catch this, but we're getting too close. If this was raised, then that would again look weird. Hmm. 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 Okay, so this is still not amazing. Also, this is again not the shortest path. I don't think. I think this seems shorter. Hmm. Hmm. I think we have to make sure that this angle right here is not too acute. I think it should be like at most 45 degrees. So uh, we look from here, we draw a line to there, we see, okay, we don't pass through here. So we go all the way back to this. At first we would draw a line to here, then to here, then to here, and then to here. And then from this position, we draw a straight line, which obviously works. We should we should just move onto this tile, maybe. And that's maybe not such a problem anymore. Well, I mean, yeah, same thing here. If we just walked onto this, so we don't want to turn on the border. We want to move onto the next tile. But then we would also do this here. Hmm. Give me 1 second. Hmm. I don't know. There's so many cases to consider. And we haven't even talked about the stairs. Hmm. Hmm. Maybe this is good enough. Oh. Yeah. We need to raise this. This is here, so this is in there. Hmm. This is strange. 0, 1, 2, 3, 4, 5, and 4. Oh, 3. Hmm. Uh, hmm. 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 I don't know. I'm not really happy with any of this. Seems like there's always more cases to consider. Hmm. 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 we still have this case, so even if this worked, then we would still walk on this line right here, which is weird. So what we could do. Oh yeah, and I think it doesn't work because we don't have the collinear case. So I don't know. Let's actually check the Pathfinder. Why do we again have so many? Oh, okay, no. For this, it's probably correct. Because we also have very many blocks. Have, have 1, 2, 3, 4. 1, 2, 3, 4, yeah. But we get nan. Position buffer 0, 0, 0. 4.54. Wait. Where's Snippy? Zero, 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 4.54, and then 6.54, and then the next one is nan. Another thing that we could do. We could say, okay, we have not one line, but 3 lines. Like here and there. And you have to pass through all of them. So you most definitely always stay inside the rectangle. But then we wouldn't need the middle one. We just need the lines on both sides. Hmm. Hmm. Well, maybe this approach is just not good. Another approach would be to use triangles like in a regular mesh. But would that really change anything? Hmm. Hmm. Why am I not seeing the collider? Hmm. Hmm. Ah. Hmm. We could also say maybe you can walk at most at 45 degrees. So you have up, down, left, right, and 45 degrees in every direction. But then we still have this kind of problem. Hmm. Mm-hmm. If we split this into two lines, one here and one there, and you always have to walk through both. Then I think that would solve most of these issues. On the other hand, we'd probably also have cases where the path gets longer than necessary. Hmm. Hmm. Or maybe, I mean, we don't have to follow this path religiously. We could say As long as there's no obstacle, we walk along here. And then we'd have to do collider stuff. That's also not amazing. That would make everything much slower again. I mean, as long as this is on the same rectangle, we can walk in a straight line. But I mean, technically, we could also be here and then walk in a straight line. Hmm. Okay, I think I'll have to think about this a little bit. So I'm gonna stop here for today. I don't think I'm gonna reach any good conclusions. So I'll be back on Monday. Bye bye.